We're going to go ahead and finish out section 2.5 on applications. This will be real quick. We're going to do direct variation and inverse variation. The easy one is the direct variation because it is going to be solved using a proportion, which we've already talked about. So when you see the words varies directly, then just think proportion. And this makes sense. You'll hear stuff like you understand your electric bill varies directly with how much electricity you use. If the more you use, the higher the bill. Your water bill, same thing. And so direct variation, um, just simply write it as proportion. That'd be the easiest way to do this. And so, for example, in this problem, you can read it and you can see the relationship between 350 people and 84,000 cans in 1 year. So set up a proportion to figure out how many cans used with 180,000 people. And we've done this, so I'll just reveal it. So the two known things you relate together 350, 84,000. 180,000 is people, got to be on top, X on the bottom. When you solve it, you're going to get X is equal to 43,200,000. Okay, so direct variation, no real change, just recognize. Now, inverse variation, a little bit different because you have to first compute this idea of a constant of variation, or they call it here a constant of proportionality. You can see it right here in the words. I've got underlined. Where's my pen? Let me get it in here somewhere. Yeah, right here. So the constant of proportionality, I call it the constant of variation. Okay, so what's this idea of inverse variation? Well, think of a water hose. A volume of water is coming out of that hose. As you pull the trigger and constrict or decrease the opening, then the pressure goes up, right? So one thing is going down, the other thing goes up. If I release the trigger and open the opening, so that is increasing, the pressure would drop. And so they vary inversely. One goes up, the other goes down. Okay. And so here you're going to have to remember a little formula and then what to do first. So the formula for inverse variation, y equals k over x, y is inversely proportional to x. And you got this constant that you have to figure out. So when you see this, first just go ahead and write the formula right here. Just same exact thing. And then substitute the given values for the variables. Okay, and it's good to use descriptive variables instead of y and x so that you know what you're substituting in. And then you will solve for k because you're going to be given the value for the y and the x. Solve for k. And then once you have k, you're going to rewrite the equation and you're going to substitute in the given value for y or x to solve for the missing. Okay, so let's just look at an example. This is just too many words. Okay, so here's just generic. Y varies inversely as x. So they give you some values. Okay, so if x is 8, then y is 3. So here is my, the y is equal to k over x. And that is the first thing you do is write the formula. In this case, my y value is 3, so I write it in. My x value is 8. I got to solve for k. Well, in this case, just multiply both sides by 8. I get k is equal to 24. Once I've solved it, then they want me to find y when x is equal to a 6. So the x value replaces x in the formula. I'm solving for y. I know what k is. In this case, just simply reduces to y is equal to 4. And it makes sense. If my x value goes down from 8 to 6, my y value must go up. So it goes from 3 to 4. So the answer does make sense. Okay, let's just look at a couple more examples. There's not much else to say. So the volume of gas varies inversely as the pressure upon it. Okay, so the volume of gas is 200 cubic centimeters under a pressure of 32 kilograms squared. What will the volume under a pressure of 640 be? Okay, so first thing is got to set up the formula to find the value for K. So if Y is equal to K over X, in this case, if you read the problem, the volume varies inversely with pressure. So I'm going to use V and P. Volume varies inversely with the pressure. Okay. I will substitute in the values they gave me for volume and pressure to determine the value for K. So here I put in the 200 for the volume and the 32 for the pressure. To solve for K, I just multiply both sides by 32. And so 200 times 32 is 6,400. I then take that K and replace it back into the formula right here. So volume varies inversely with pressure. I've got the K. Here they gave me the pressure of 640. They want me to solve for the volume. Well, I can just substitute it in, and this is just a simple division, and you get your answer. They could have given me the volume and asked for the pressure. It doesn't matter which they give you. Just put it in the right place. Okay. We'll do one more real quick, but there's not much else to say about this. The key thing is that you do understand the process of finding K. So in this example, capacitive reactance X in a circuit varies inversely as the frequency of the applied voltage. Okay. So the Y in this case is going to be X, the capacitive reactance, and the X in this case is going to be the frequency. So X is equal to K over F. I substitute in the values given to me, 503 for the reactance, when the frequency is 60.6. So multiply, and I get K value of 30,481.8. I replace K with that value right here. Okay. And let me just go ahead and completely kill this right here. And then what do they give me in the to find? It says find the reactance. Okay, that's the X when the frequency, the F, is 46.3. So I just make sure I put the values in the right place. So there's my 46.3 right there. And again, this one's just going to be a division. I do the division. I get X is equal to 658.4. Okay. So in summary, direct variation is just a proportion, inverse variation. You got to know the formula. You got to find the constant of variation, plug that in, and then solve the problem with the new values. Okay, good.